Okay, this is the overview for the quotient rule. And the quotient rule is pretty important, okay? And you are going to get 2 or 3 quotient rule problems in the exam. And it's related, I guess, very similar in structure, but dealing with different aspects than the product rule. Okay, so the quotient rule, if you forget it, you can obviously consult your formula sheet. Third page, tucked between the product rule and the chain rule, there's the quotient rule there. Okay, quotient. If you look at the definition here, stolen from the Google search, a quotient says a number resulting from the division of one number by another. In other words, it's a fraction. Numerator divided by denominator. Okay, so um, let's look at these problems here on page 112 to 113, and you will straight away see fractions. Can you see fractions? Yep, you can. That numerator, denominator. Square root x over 4x plus 5. This side, natural log 2x over x squared. Here goes some trig stuff. Cos x over 1 plus sine x. So we can see a fraction. So the quotient rule is giving you the skill set to differentiate between fractions. Differentiate a fraction expression. That's the wording got there. Okay, so let's just do it. Righty. Very quickly, how to learn this. You'll find the PowerPoint's really good. And Mr. Infinity Plus here, Mr. Chanda's videos are really good. I'll just plug down the bottom here. Nancy Pie is also pretty good. Look at her 2 videos here, how she does her analysis. You will find some good examples there as well. So obviously STEM Online, opportunity for you to look at their structure and do some drag and drop, giving some feedback, instant sort of success. The program's telling you how you're going. But the key thing is, can you do these problems is the key thing. So what I'm going to do is do a very simple one first, and then a more demanding one as a problem here. Okay, so let's go to, here is the simple one. Let's say we had y equaled, oops, get on the focus there, please. X plus 2 over, I don't know, x minus 1. Okay, now product rule. You could say that is x plus 2, x minus 1 minus 1. And if we did the product rule here, in fact, let's just do the product rule. So if we said let u equal x plus 2, v equal x minus 1 minus 1, just running out of room there, annoying. Okay, u dash is 1, v dash is, now that becomes down, that's minus 1, x minus 1 minus 2. Okay, and the product rule says multiply these things out. So you've got y dash equals that times that is going to be x plus 2 times by negative 1 over x minus 1 squared, and add on plus 1 over x minus 1. That's right. Okay, so there's the product rule. And you could do some simplifications there and so forth. But trust me, the quotient rule is actually probably better to do than the product rule here. So the quotient rule says you let u equal the top bit, x plus 2, and v equals the denominator, x minus 1. So the product rule says y equals u over v. Okay, and then underneath it, u dashed is 1, v dashed is 1. Okay, now here's the tricky bit, y dash. Okay, so the tricky bit here is you've got to, the product rule is easy, you just do the diagonals. Doesn't matter which way you do the diagonals, right? But the quotient rule, if you do the diagonals incorrectly it's wrong. So you have to follow the coding in here. So the top part on the left here is v times u dash. In fact, let's just put that here. It's v times u dash minus what? U times v dash. And the whole thing is always divided by the bottom thing, which is going to be v squared. Now, it just works. Okay, just confirm that. We had that there is dv by dx. Okay, so there's the code. Now, if we look at this, basically, that there is this diagonal. Okay, so that diagonal first. Okay, so in other words, it's going to be this thing times this. X minus 1 times that. And then you put a minus sign, and then u is this thing, x plus 2 times that thing, which is just 1. And the whole thing is over what? This thing here squared. Now, let's just finish this off. So if we were to expand this numerator bit here, we're looking at x minus 1 minus x minus 2. Hang on, let's just look at x minus x and minus 2, and that's over x minus 1 squared. So this is looking to be, well, x's cancel, minus 3 over x minus 1 squared. Now, in theory, this is going to be interesting. This here should be the same as this. Okay, as it stands, we've got minus x minus 2 over x minus 1 squared plus 1 over x minus 1. Is that the same as that? I'm going to argue it is. In fact, I'm going to do a proof over here. I'm going to make this the same as this. Now, okay, we've got two terms here. This is just one term. Okay, now what I'm going to do here is change a pen. Let's go to green, and I'm going to times, I'm seeing this here has x minus 1 squared. So, and the pen don't work. Yeah. Okay, I'm going to times both sides by x minus, well, here. Okay, I'm going to times that by that. In theory, I've done nothing to it. So, but what I've got is minus x minus 2 over x minus 1 squared plus 1 times that x minus 1 over, that's the same thing. Okay, hey, they've now got the same bottoms, so that means it is x minus 1 squared. Now, minus x plus x cancels out. Minus 2 minus 1 is minus 3. Okay, I think you'll agree that was actually quite fiddly, and this here was actually quite doable. Okay, so not the easiest problem to work through, but hopefully you can see the logic. I've just started one here, and this one here was actually easier than this one here. This one here is it looked pretty horrible. There it is, 208. 3ex squared plus 1. Nope. Sorry. Yeah, this one, 206. Minus 4e minus negative 3x over 5x squared plus 2x. Okay, so let's just go through this one here. I've got the top bit's going to be my u, the bottom bit's going to be my v. I write it down here. U equals this thing. U dash, differentiate this. Now you should be familiar with exponentials here. So the minus 3 multiplies out, and that doesn't change. So it's 12e negative 3x is the derivative. Here, v is this bottom bit, 5x squared plus 2x. And not sure I put brackets around it yet, but differentiate that, you get 10x. Now, how do we do the derivative? Okay, the coding was y dash equals. Now, look what I'm doing. I'm just going to get the coding here sorted. V u dash minus u v dash over v squared. Okay, so basically here's the coding. So one way of doing it is you just sort of recognize the pattern. Start in this corner and go this way. That's v times u dash. See that? V times u dash. So it's going to be equal to this thing times this. So I'm going to put here 12e minus 3x bracket 5x squared plus 2x. So I've done that bit. Now minus this diagonal. Okay, minus minus. That becomes a positive. Well, that's tricky. That times that, 10x plus 2. And that whole thing is divided by this thing squared. So that thing is going to be 5x squared plus 2x squared. Okay, now, technically, I'm hoping that's the answer in New Lake. They may have taken a common factor out. You can sort of see there's two terms there. You've got common factor of 4, 12, 3 times 4, and this e thing. But let's just check the answer. The question was 206. A bit nervous here. Let's see what the answer says for 206. Okay, 206. Interesting. Yep. New Lake has done some extra work. I haven't. So this is what New Lake have done. Okay, you notice the E3X is on the bottom. So that, okay, so it looks like they have done some extra work here, so I'm not going to be lazy. I'm going to take common factor of, let's just drop the E3X. So you're going to have 12, what am I saying by drop it out? Did they drop out the E? No, they left. Okay, so we're going to take out E minus 3x. What's left? 12. 12 times that, or 12, 5x squared plus 2x plus 4, 10x plus 2. Let's put square brackets in here. Let's not worry about the bottom bit at this stage. So that thing can now drop down. So it's going to be, now 12 times that's going to be 60. 12 times 5 is 60x squared. 12 times that is 24x plus 40x plus 8. And that thing here drops down to give you E3x and bracket 5x squared plus, what's that, 2x to the power of 2. Now simplifying this top line, 60x squared plus 24 plus 40. Well, those two are the same thing. Okay, this is getting messy. Apologies for this. 6x squared plus 64x plus 8 over E3x 5x squared plus 2x squared. Got there. Okay, and that is the answer. 60x squared plus 6x plus 8. Woohoo. Now, the good news is some of you are stressing out watching this. If you actually wrote that down, you would get the merit tick potentially. You do not have to do the algebra to get the final answer as shown. The full algebra, it's still the same thing. Okay, but here you could argue it is a very neat, elegant solution as would be required by textbook New Lake. That said, if you're going for the merit or excellence in the external, you should be in a position where you're starting, to really challenge yourself to algebraically get it to this level. And it just comes with a lot of practice, and you'll get there. Okay, hopefully I haven't stressed you. The key thing is really encourage you to watch these videos. Yeah, there's 2 or 3 hours work and just here on really getting yourself up to speed with the quotient rule. Hope it goes well. Don't forget, I'll probably add some more examples here at some stage, but yeah, if you're struggling on one, let me know and we can do that in a Wednesday VC session.